any number divisible by 2 exactly without the remainder. So you know them. 2, 4, 6, 8, 10, 12, on and on and on. How do you identify that a number is an even number or not? If the number ends with these numbers, these digits, if a number ends with this digit, 2, 4, 6, 8, and 0, it means the number is an even number. So if I write 7, 9, 3, 1, 4, because of this 4, this whole number is an even number. If I write 9, 4, 5, 3, 0, because of this 0, the whole of this number is an even number. So this is a strategy you can use to identify. Therefore, it will be divisible by 2 exactly without a remainder. Take note of that. Take note of that. All right. The next thing is odd numbers. Odd numbers. Odd is the enemy or is opposite of what? Even. Odd means separate. Odd. Oh, you look so odd. That means you are separate. So there will be one separate. Any number you divide by 2, right? And there will be one left separate. That number is an odd number. So the first one is what? 1. So they normally leave 1 out. They start from 3. It's 1. Because there's assumption is that you can, if you divide it, you destroy it. So you divide this by 2, you get 0.5. Right? So you have a piece of a loaf of bread. If you divide by 2, it's not complete anymore. It's not complete. And we don't want it to. We don't want any half portion, right? You don't want any fraction portion. We want a complete thing. So any number that is divisible by 2 with a remainder, with a remainder. So if you divide by 2, there'll be a remainder. So if you have 3 items and you're sharing, you divide it into 2 equal parts, there'll be 1 left. Remainder 1. 5, you'll get 2, 4, 2, remainder 1. 7, it will be what? 3, 3. 3, 3, remainder 1, right? 11 will be what? 5, 5, remainder 1. So all those numbers, don't forget, it begins from 1. Because it's impossible to divide 2 equal halves without destroying it. Take note of that. Now, the next thing is to identify this, just as we did for even numbers. If a number ends with an with an odd digit, that number is an odd number. Odd digit. I know the odd digit. 1, 3, 5, 7, 9. If a number ends with any of these numbers, the number is an odd number. Is it a secret? You should be able to identify numbers and straight away you can think and apply them. Right? You can think and apply them. So take note of this. Very important for you to note that. All right. Good. Now on whole numbers. We are now on what? Whole numbers. We said whole numbers begin from 0. If you just put 0 in front of counting numbers, you get whole numbers. This up to what? Infinity. If a set of number is written and see dot dot at the end of it, that means the last element is not known. So we call it finite set. Finite or is it infinite infinite set or what? Indefinite set. So when the headmaster says or school authorities say they have dismissed a student indefinitely, that means you can't tell when he's returning. It's not known. The date of return is unknown. So if the last element is unknown, you see this 3 dot at the end or even more dots, right? But if it's terminated, you see the curly bracket here. It means the last element is what? 5. And for that matter, that set is finite set, rather. It's finite or definite set. That means the last element is known. Now, whole numbers. Why whole? Whole means complete. When you say whole, it means that something is complete or full or intact or that is the total. See, if I have 10 oranges, that is the whole oranges I have. The whole, that's the total number of oranges I have in a basket. Right? So if I pick some out, if I pick 3 out, how many remain? 7. Right? So at that stage, what I have picked is 3 out of 10. What is left is 7 out of 10. So this one becomes fraction. Fraction. So give me a fraction of your money. That means a portion of your money. Right? So at any stage, the total, the number you begin with, the full complement you begin with, right? What you started with is always whole until part is taken away. So if I have 0 oranges, right? That is the whole oranges I have. That's the whole oranges I have. That's it. It's 0. That's the total. So that's why 0 is a whole number. If I have 1, that's the whole I have until I take a portion out. If I have 200, that's the whole I have. So whole numbers are numbers that are complete in themselves. It is a total of every situation. Hello, I hope you have gotten the picture very well. You have gotten the picture very well. So if a portion is taken out, it becomes a fraction, which is the portion taken out of the total, out of the whole. So fraction is out of a whole, right? You can define it that way. Fraction is out of a whole. All right, so you can see it here. This is a simple scenario to demonstrate that. So in a class of 20 students, so the number of students are how many? 20. 5 are girls. So this implies that the number of girls is what? 5 out of how many? Out of 20. Yes. And this can be simplified further. 5 we divide here 1, then 5 we divide here 4, giving you 1 out of 4, as you can see over here. Do you understand? Good. So what will be the fraction of boys? The class is 20. The fraction of boys will be what? 15 out of what? 20. And this can also be simplified further. 5 here 3, 5 here 4. So 3 out of 4, 3/4. So this is 1/4, this is 3/4, or 3/4. So that is how it works. That's fraction. It's a portion of the total. So the total given will determine. Therefore, when it comes to percentage, it's also a fraction. Percentage of a fraction. Yeah, you know that. Percentage is also a fraction. And it's 100%, right? So if 30% are girls, then what is the percentage of boys? So if you want to know the number of girls, it is 30% out of the 100%. You do your cancellation out. This cancel that, right? So you get 3 out of 10, which is a fraction. Do you understand? Good. The number of boys will be what? 70% out of 100%. When you cancel out, you get what? 7 out of 10, which is a fraction for the boys. So that is how it works. It's a portion of the total out of the whole. All right.